All right, so we're going to add and subtract these fractions. Our first job is to find the common denominator. So you want to find the least thing that both of these will divide into. So 8 and 5. I always test the biggest one to see if 5 will go into 8. And it will not. There are two methods. You can do the multiple method, which is taking the larger number times 1 times 2 times 3 until you get the one that the other will go into. And I think that it probably is 40. So I'm going to just put that here, and then I'm going to show you the other method. And that is just when you get to 8 times 5, because there wasn't anything in common before that. The other method is called the prime method, and it is actually more similar to what we'll do with these pieces that we'll have, which will be like x plus 2 times x minus 1, that kind of thing. So it's not just numbers. The prime method breaks everything into primes, all the denominators into primes. And then you have to take every type of factor you have. You take it from the one where it occurs the most. So we need 2's, and 2's in one fraction occurs 3 times. And we're going to need a 5, and in one fraction it occurs 1 time. And when you multiply that, you get the 40. I'm going to just make up a problem here. So I don't even care what the numerator is. Let me just make some denominators, and I'm going to leave them already factored. So big, it's big, right? And we'll say we have one with a 2 and 2 5's. And let's say this one also has 3 3's. All right, so when we pick the common denominator for these, you have to have every kind of factor that's there. So we would have had to break to these primes first, right? So we have to have 2's, 3's, and 5's. You take it from the one fraction where it occurs the most times. So when we have the 2's, this one has the most. So we're going to need 2 2's, right? And then we have the 3's. The 3's are the same amount. You can take it from either one, but you'll need 3. For the 5's, this one has 1 5, this one has 2, so you have to take the 2. You don't also need the other one, because it would divide into that. And so if you multiply this mess out, that is your common denominator. It is pretty big. Let's see, we have 25 times 4 would give us 100 times 27. So if I'm doing that right in my head, it's about 270. Okay. But that shows better because I have more types of factors, what you're doing. And this is really the same type you use for the common denominators we'll have in these other problems. All right, so let me get that out of the way and go back up here to this problem. And once you figure out what the common denominator is going to be, you're going to add on the missing parts. So for 8, we have an 8, we want a 40. We need to multiply this by 5. And that would get the 40 in the denominator. You have to do the same thing to the numerator. For the other fraction, we have a 5, we want a 40. This one is going to need an 8. And you do the same thing to the numerator. So we have 5 over 40 plus 8a over 40. And then your rule is keep the denominator. You don't do any more math on the denominator. And combine the numerators. But these are not like terms, so they can't really go together. That is all you can do. You have to leave it there. All right. If they all had a common factor, you could divide it out, but that is all you can do. So that kind of gets our rules, and I left that just so it would be on that page. All right, let's go to another one, and let's see. I did go ahead and pick this one. So these next couple of questions, they're not actually having us add them. They want us just to find the LCD. And before you can do that, you will factor. So we have to see what's there. So this is like going to primes, except it's just factoring with your letters in it. Right, so we're going to have different signs. Split your C's. And we're multiplying to get 40 and subtracting to get 3. Let's see. So I think 8 and 5 is going to be the choice. So 1 times 40, 2 times 20. 3 doesn't work, 4 times 10, and 5 times 8. 5 times 8 will work to get us a 3, so we want a plus 3. So we need a plus 8 and a minus 5. Those are two types of factors, so they're going to have to both be represented. All right, let's see what is in the other one. So you have to factor it. So there's your C's, different signs, and 72. We're multiplying to get 72 and subtracting to get a 1 here, a minus 1. That is going to be consecutive numbers when you have that. I'm thinking 9 and 8. And this sign with the middle is going with the bigger 1. So we're going to do a minus 9 and a plus 8. All right, so these are all the types that we have. They all have to be represented, but you take it from the one factor where it occurs the most. So when you pick out your C plus 8, they are the same, so you only need one of them. You don't need two. So we have a C plus 8. You're going to have a C minus 5, and you're going to have a C minus 9. So that would be the common denominator. All right, let's do one more of those. So question number 4 is going to do that also. So it's just find the LCD, least common denominator. That's what that stands for. So you don't even really care what's on the numerator. So you have to factor these. And they're not very nice for factoring. So we'll go through that. On this first one, before I even tried to factor it, I would take out this negative 1. Right, and that is going to leave me 2a squared minus 5a and plus 2. Right, so I have pulled that out. I could actually move that up to the numerator, that negative, and it wouldn't matter where it is. So it's not really going to affect our common denominator, and it makes it easier to factor without it. All right, let's see what we can get here. You can try trial and error, or you can do it and make a grouping problem. I'll go with trial and error and see if I can come up with this. All right, so it says do like signs both minus. All right, your choices here are 1 and 2 or 2 and 1. And we did that one shortcut where you're not going to get a common factor in the same parentheses. So this one is not going to work, the 2 and 1, 2 and with 2. So we'll try 1 and 2. And this is a minus 4a and a minus 5a. I'm sorry, minus 1a, and that gives minus 5a, which is what we want. So this is the proper factoring on the first one. So I'm just moving that. Right, and then I'm going to try this one. All right, so we're going to do a 2a and an a, like signs both minus, and 3 and 1 or 1 and 3. Those are your choices, and they're going to add to get a 7. I believe it's going to go this way. So there's a -6 on the outside, -1. That gives -7. Right. These are the types of factors you have. You take it from where it occurs the most. So we will only need 2a minus 1 one time. We will need a copy of a minus 2, and we will need a copy of a minus 3. So that should be our LCD. And hopefully we won't have any problems. We'll look at this, okay? Ours is really the same. This one right here, they have the negative in it, negative a1 plus 2. If you factor that negative out, right, that would leave a minus 2. So we're good. You know what? Let's type it in and see if they're going to scream about it. So 2a minus 1. And some more parentheses, a minus 2. And some more parentheses, a minus 3. Oh, they did scream about it. I think they're wrong, okay? Because you can move that negative up to the numerator, and you wouldn't have to have it. And that changes this one. So perhaps that is a trick that they didn't expect. If something like that happens to you, you can let me know and I'll override. Okay? All right. Let's do some problems then where we actually do some solving. And we can go back to problem 1. This is a nice standard question, but it's going to take a little bit of work. Right, and so these are already factored for you. So your common denominator is going to need an x minus 2 and an x plus 1. It's going to need them both. And so you're going to just put on the missing part. So I'm going to bring down what I have and put on the missing part. So this one needs an x plus 1. And you have to do it to the numerator and denominator. Right? And the other one, bring down what I have. And then this one has the x plus 1. It needs an x minus 2. We go on numerator and denominator. Now, if you think about what happens in your problem, once you have the common denominator there, your next step is keep the common denominator. So you're not going to do any more math on the common denominator. And so I'm going to just go ahead and keep it in the answer. Either order, it doesn't matter. So I'm keeping the common denominator. Don't multiply it out because you want to have to reduce at the end, so you want to see if it'll reduce. Now, the numerators combine though, so you actually have to simplify all them. So you do have to distribute and make sure you watch this sign. We'll go with that 5. All right, so we're going to get a 5x plus 5 plus 5x and minus 10. All right, and we'll combine those. So 5x and 5x is 10x minus 5 over x minus 2 times x plus 1. And you have to see if this will reduce. On the numerator, you can factor out a 5, a GCF. So 5, and that would leave 2. And 10 will go 2x minus 1. right? So it's not going to reduce. Since it did not reduce, we could have left it. So it should accept either answer here. Because you really have to go through this thought process. Since it didn't do more, the other one is acceptable. And I'm going to type answers in to just make sure. All right, I'm going to type in the top one because it did not reduce. Whoops, you better put an X on there. All right, and this, I'm going to leave that denominator factored. That is standard practice, not to multiply that out. And an X plus 1. Good. So that's a nice standard question there. I like that question. I didn't like that one. Okay. I'm going to skip 5 and come back to it. Let's go to 6. 5 is a special case. All right, so 6. We have 4 over x minus 6 plus x minus 54 over x squared minus 36. So you're adding fractions. Your first job is figure out what the common denominator would be. So you need to factor both of these. First one's done. This one is a difference of squares. So x plus 6, x minus 6. Right? So you need both of those kinds of things. You only need one copy of x minus 6. So you need an x minus 6 and you need an x plus 6. That's good news because the second fraction's already done. You're just going to have to do some work on the first fraction, and I'm going to just write it right beside it. Okay, so it has the x minus 6. It's going to need an x plus 6, top and bottom. All right, now remember that the job of these pieces, the denominators you keep. All right, so I'm going to keep it in factored form. But numerators combine. So I have to multiply this one out. So I have 4x plus 24. This is a plus here, so no sign changes. So plus x minus 54. Right, and then we'll combine. This gives me 5x. And this will be different signs, subtract, and sign of the larger. So minus 30. Over this, and I believe this one will reduce. So we can take out a GCF there of 5, and that will leave x minus 6 over x minus 6 times x plus 6. You do have pieces that will cancel out. So the final answer there will be 5 over x plus 6. If you left it here, because it would reduce, they would mark you wrong. So go here, 5 over x plus 6. Good. All right, question 7 is going to be a similar one. We'll go ahead and do it. That way you'll have plenty of examples. It's going to be nice because one of the fractions is already going to have everything. When you factor, it's going to have some of the same pieces there. So we pick the common denominator. This is a difference of squares on this first one. So w plus 5 and w minus 5. And so our common denominator is going to be W plus 5W minus 5. That covers the other one. So this time, the second fraction needs some work. It needs a W plus 5. Top and bottom. All right. And eventually then we keep the common denominator. So we're going to just keep it in factored form. No reason to multiply it out. But we combine numerators, so they have to multiply out. First one is good. It's already multiplied out. So 4W. This one we're going to get a W squared, and it was plus here. Kind of watch that. Plus 5W. Right, so I am going to reorder that and factor it. So I have a W squared plus 5W. Wait a minute. Let me look close there. All right, I can go ahead and put those together. I was seeing that as a trinomial, which it's not going to be. Those are like terms. So I am getting a W squared plus 9W. Am I doing that right? Yes. Now, you could factor that a little bit, but it's not going to give us anything that will cancel. It is has a GCF. It has a W in it. That's an S. Okay, but it would leave you W plus 9. W plus 9 doesn't match those. So I'm just going to leave it there. You could try to factor, and it would take out W and leave you W plus 9. That doesn't match anything, so you might as well leave it. All right. They kind of split up the boxes here. I'm not sure why they have that done, but all right. So W to the second, and then we're going down. Plus 9W over parentheses. I like that parentheses button. W minus 5. And another parentheses. W plus 5. Good. All right, let's do one more, and then we'll go back and do that one I skipped that I said is a special case. All right, so we have 5W minus 8 over W squared minus 3W, and it's 54, plus 3 over W plus 6. Factor your first denominator. Hopefully it gets a W plus 6 in it. All right, so different signs. And we can use 9 and 6. And the 9 will get the sign of the middle. All right, so that should work. And it did give us a W plus 6 in there. So our LCD is going to be W plus 6 and a W minus 9. So your first fraction actually has everything. The second one, we're going to put on the missing part. So it has a W plus 6. We're going to put on there the W minus 9. And I'm just going to squish it there. All right. So I wrote more on this one than I did the others. All right. So I'll just go ahead and continue in that format since I started that way. We need to multiply out the numerators, and this is a plus here, so plus 3 to distribute. So we have 3W minus 27. All right, now keep that common denominator. So W plus 6 and W minus 9. Combine the numerators, so 5W plus 3W is 8W. And your constants, these are like signs, so add. And this gives us a 35. Right, and we would try to factor to reduce. There is nothing common in this, so that is actually going to be the answer. They have split these parentheses up again. We'll look and see what they have. 8w minus 35, and good. So we're good. All right. I'll do that one in a little bit. Let's go back to the one I skipped. Number 5. This one has what we call opposites. Opposites are negative reciprocals for denominators, and you only need to pick one of those because you can force the other one to match. Right, when we simplified with them, we factored out a negative one. Here we're going to multiply a negative one to make the signs change. So when we see these, they're turned around and they both have minus. You can pick either one for your LCD. So x minus 10 or 10 minus x. And your answer is going to look different depending on which one you pick. I like to pick the one that looks normal. So the x minus 10 is what I'm going to pick, right? That means my first fraction is good. I'm going to bring it down. Right? The second one, to make this into x minus 10, because that's what I've chosen, I need to multiply it by negative 1. So I'm going to do it times negative 1 over negative 1. And that's okay because that's really 1. You're always allowed to multiply by 1. Right, so that is going to give me a 3x on the numerator, a negative 3x. Right, but look down here. It's going to give you a minus 10 and a plus x. And you're allowed to change the order, which would be x minus 10. So multiplying by that negative 1 gives you exactly what you wanted. That's all you needed to do to make it match this one. All right, but remember, you also had to do it to the numerator. All right, now you keep the common denominator and combine numerators. So we have 7x minus 3x is 4x plus 4. You would see about reducing. If you take out a 4, you're left with x plus 1. That is not going to match x minus 10. And so this is our answer. And we'll just type this one in. So 4x plus 4 and x minus 10. Okay. If you pick the other form, the 10 minus x, you would have had to multiply this one by negative 1 over negative 1, and it's just going to switch up your signs, but it actually is equivalent. And the way you can check your final answer that it's the same as this one is multiply it on top and bottom by negative 1. That's a nice thing to know for higher level classes when you get answers that don't look alike but you think you did everything right. But if you see something that's backwards there, try that. Multiply numerator and denominator by negative 1, and it will probably convert your form to the other one. If they are equivalent, it will. All right, so I think I picked up all the ones I had skipped. And have to save plenty of time because we have 2 sections on the agenda today. This one we did. All right, this one is going to be a little bit more complicated. It's similar to the first one, as in it is a standard problem, but you're going to have to do a binomial times a binomial, and you'll have to do it 2 times. So that makes it a little bit more work. On the first problem we did, the numerator was a monomial, so that made it a little easier. So for your common denominator, these are already factored. You're going to need both. You're going to need a p minus 3 and a p plus 4. That will be your common denominator. So both of them are going to need something. This one is going to need the p plus 4. And we're going to have to multiply those out, so I'm just going to stick it here. Right, this one is going to need the p minus 3. Now, denominators, eventually you just keep, so we don't have to multiply them out. You can pick either order. But these numerators, we have to multiply all that out. So we have 2 FOILs to do. So we have p squared on the first one. Right, outside we're getting 4p. We might do outside and inside together, all right? I'm taking a little leap there. 4p plus 8p is how I'm going to get 12p. And 4 times 8, last terms, is 32. All right, now I have to do the same over here. This is plus, so that makes it a little bit easier. If it's minus, I need to take it with me. All right, so I get p squared. Right, outside I'm getting minus 3p, inside plus 9p. That will give me a plus 6p. And you write all those if you get in trouble doing that. All right, and then the last terms is a minus 27. All right, so we're going to put all those together. So we have 2p squared. 12 and 6 is 18p. 32 minus 27, 12 minus 7 will be 5. And hopefully I have that all right. Now you have to check and see if this numerator will factor. So I have primes in both. I'm going to try the trial and error. So 2p and p, and like signs both plus, and you can do 1 and 5 or 5 and 1. If I do 1 and 5, that's going to give me 10 plus 1 is 11. That's not going to work. If I do 5 and 1, that's going to be 2 plus 5 is 7. That doesn't work. That's all the choices there are. So it is not going to factor. We thought about it. This will be the final answer there. Let's see what they wrote. 2p squared plus 18p plus 5. And they left the denominator factored. Good. We did go through the thought process, but it didn't factor. Okay. Let's see if anything looks really different. We did one very similar to that one if we did not do that one. This one is just like the one we just did, so we can skip it. Let's do 12. So 9 over x minus 5 minus 2 over x. For your common denominator, you're going to need both of these. This is a binomial, and it all goes together. So we need an x and an x minus 5. That means we have to work on both fractions. First fraction is missing an x. Second fraction is missing an x minus 5. So we will keep that common denominator, and I just like the monomial first, so I'm going to put it first. And we're going to combine numerators, so we have a 9x. Here you have to be real careful. This one has a minus there. Take it with your 2, and it's going to distribute. So a minus 2x and a plus 10. All right, and so this gives us 7x plus 10 over x times x minus 5. 7x plus 10 does not factor, so we're not going to get any reducing. So we'll click in there. You need the fraction button, and 7x plus 10 over x, and we'll use parentheses there, x minus 5. All right. This one will be similar. You just have to factor out your x here first. So it's x times x plus 4. And then this one would just need a piece. We'll skip it because it wasn't too different from what we did. All right, let's do 14. And then we can stop in this section and do the other section. So that's a lot of work for you guys this time. The other section is a little bit more fun than this one, I think. This one is not very fun. All right, so if you have some fractions that you're adding and you have some that are whole numbers, what I would do is I would make that 6 look like a fraction, and I would put it over 1. So your common denominator here is going to be 7w plus 6. So first one is good. The second one is going to need a 7w plus 6 and a 7w plus 6. We will keep the common denominator, 7w plus 6. Combine the numerators, so these are good. 5w minus 2. Bring it down. Watch out here, you have a negative in there. Take it with your 6. So we have a negative 42w and a minus 36. We will put like terms together. So 5 minus 42 gives us a negative 37w and a minus 38. Right? You could factor out the negative 1. That's about it. And so this is not going to reduce. Let's just look at the answer. So we're good there. Let's go ahead and do that 15. You're going to be able to do opposites, I think, there. But we only practiced with 1. So we need to factor on this one, and that will give x's different signs, and we can use 9 and 4. It's going to work. And so we want the bigger number to get the plus. So 9 will get the plus and x minus 4. And this is going to be opposites. X minus 4 and 4 minus x are opposites or negative reciprocals. You can use either one. You don't need both. Right? So I'm going to use the one that looks in the regular direction. And we'll just have to do some work on the other one. So the first fraction is actually good. I'm going to run out of room. So I'll leave it. And then the other one that I'm going to work on, and remember to make this denominator, to switch the order, if you multiply it by negative 1, it will do that. You have to do numerator and denominator for that to be okay. All right, and so when you distribute this one, it gives you negative 4 plus x, which you're allowed to change the order, x minus 4. So that is going to give you the x minus 4. So we can go ahead and keep that common denominator, and we'll combine on the numerators. This one, we'll just bring it down. Right, this one here, you have to watch out. You've got a minus here and a minus here. They multiply, and make a plus. And then these two can go together. So we have a 6x plus 7 over x plus 9 and x minus 4. Let's see if that's what they say. Oh, wow. That doesn't look like that at all. What did I do wrong? I think they're wrong. All right, I'm going to type mine in. But it's not equivalent to that, to what they wrote. Unless I copied wrong. No, you had everything in the first one. All right, so 6x plus 7 over parentheses x plus 9 parentheses x minus 4. Okay. I'm going to just pause a second here and do a screenshot of that. I would put it on my other screen. Let's see if I'm able to move it down here. Okay, now I can save that. I didn't do anything obvious that's wrong, did I? I don't think so. Because this one had the x minus 4. Right, so you did not need an extra piece on it. There is no way to get the x squared there. This one just needed a -1 to convert it. And you should not have got that, right? And I will double check that for you guys. I think we're going to leave this section. I am going to check on that for you guys because it's going to mark you wrong too. Okay. Let's go to our next section. And this one is complex fractions. So it is Mod 7 Homework 4. Right, and it is complex fractions. And a complex fraction just means it has a fraction in a fraction, and you're not allowed to leave an answer like that. And so you have to clean that up. For these that only have one piece in the denominator, I'm going to show you 2 ways on this one problem, but really the other method is better because it works on everything. You can write this across instead of up and down. So we could write this as 2 over 21 divided by 1 over 7. You change division to multiplication and invert the divisor. So keep your first, change, and this one flips. And you can cancel on the diagonals. 7 goes into 21 3 times, and then multiply across. So 2 times 1 is 2, and 3 times 1 is 3. And that will be your answer, 2/3. The other method for this, and I'm going to do it on this problem because this is a nice one to see it on. So same problem, a different way. And for this particular problem, it doesn't matter if you do it that way. Okay, find the common denominator of all the denominators that you have. Well, it's going to be a 21. We're going to multiply up here by it and down here by it, right? That's okay to do because I did 21 over 21, which is 1. It is going to cancel this denominator and leave you a 2. And this 1 to 7 will go into 21 3 times. 3 times 1 is 3. And it's done. The beauty of this method is when you get pieces here with binomials, where you would have to add or subtract to actually get a common denominator, you don't want to go through all that. And you don't have to with this method. All right. We'll look at number 2. And this one really is not as common a problem as you really see in these. Because it's monomials, it's really considered an old question. So we have 33x to the 7th over 14y to the 6th over 55x to the 5th over 2y squared. So we'll do it with the finding the common denominator method. So we're just looking at these denominators. So 14 we're going to use for the numbers. And for your variables, you're going to go with the highest exponent. So we want y to the 6th. Don't mix it up with GCF, which you went with the lower because it had to be common. All right, so 14y to the 6th we're going to put up here and down here. Right, and this cancels your 14 and your y to the 6 cancels. Right, and so what you're left with there is 33 x to the 7th. Down here, your 2 will go into 14 7 times, so we're going to have to do the 7 times 55. Let's go ahead and do the y. 2 will go into this 4 times, so we're going to have y4 left. So we have 55 times 7. Whoops, wrong button. 55 times 7. 385. X to the 5th and y to the 4th, and we actually still have something in common. Here we have x's that we can subtract. All right, let's see, 13, yeah, that's not going to reduce. I was looking to see if 3 would divide into this, but it doesn't divide into the sum of those digits, so it shouldn't divide into 385. So we're going to keep the 33 and the 385. The x's are going to subtract exponents, leave us x squared, and the y will stay as it is. Get this out of the way. So that should be our answer. We will just look at the key. Okay. So it had something else in common. Wow, Mrs. H is striking out today. Let's see if this fraction will reduce. All right, I got the variables right. That is good. Okay. So to reduce a fraction, 33, fraction button. Actually, on this calculator, I think I have to hit the fraction button first. Nope. All right, 33, fraction button, 385. Enter. It reduces. Okay. So I was thinking it would not reduce. It has a factor of 11. That's what divided in there to give us these numbers. So you can always double check on your calculator about whether something weird would reduce. So 3 over 35. I was checking if 3 was in there, which was not. I didn't check 11. There you go. Okay. So don't forget you have that tool. Okay, this one looks scarier. It's actually easier. So not giving me horrible numbers. And so I'm going to do them all with that method. So your LCD here is going to be x minus 12. So you're going to do an x minus 12 up here and an x minus 12 down here. And that's over each other. So that's a 1, and that is always okay to do. That is called your multiplicative identity. And it cancels down here, and you are left with 5 over 16. Pretty problem. Okay. The next one is also going to be nice. We have x plus 3 over x and x minus 4 over x. Your LCD is x. So we'll use an x up here and an x down here. And they're going to cancel out. And so you are left with x plus 3 over x minus 4. Remember, you do not cross off any of those. You would have to factor to see if it will reduce, but it doesn't factor. So that is your answer. All right. Number 5. This is one that is a more common question to see, where this method is really good, and especially number 6 is nice for this technique. So I have 5 over x plus 1 over 4. The only denominator you have in all of this is an x. This is 1 over 1, and you can write those if you're concerned. So x is my LCD, but I have to put it beside every single piece, whether there's a fraction or not. On this one, cancels out, so it leaves me a 5. But now here I'm going to have 1x, or x. On the denominator, I have 4x. So I have 5 plus x over 4x, or x plus 5 over 4x. And it should accept your answer in either order. So you do have to multiply it, whether there is a denominator or there or not. You have to multiply that by every piece. And I didn't really use 2 x's up here. I just distributed. So I had an x on top and I had an x on the bottom. And this one I distributed. I like to write it beside each piece, but you're really distributing. You're not putting more x's up there. All right. Let's look at this one. This is a good question. Right, so you have to find the common denominator, and actually it's going to be a little bit more work than I thought. Definitely we'll have an x, but these don't have anything in common, so we're going to have to use them both. So 8 times 7 is 56. So our LCD is going to be 56x. That's what we're going to use. We're distributing it. 56x up here and 56x down here. I'm going to write it beside every piece. So I'm going to go ahead and distribute it. And then I'll clean up. Right, so let's get a different color going here. The x goes out. That one leaves you 56. This one, 7 will go into 56 8 times. Right, so I better put these back so I'll know. So I have, the x is gone. So I have 56 times 1 is 56. And this one I have 10 times 8 is 80x. All right, this one, the x will go out. So 56 times 1 is 56. And this one, 8 will go into 56 7 times. 7 times 3 times x is 21x. And you can't do anything else with that. You cannot divide out the 56 over 56. And there's nothing you can factor out here that's common so that you could get this to reduce. I better be careful there. There is a 7 in that. Let's see. So 7 times 8 plus 3x. 7 eighths are 56, and that would be 21x. And down here it is an 8, and that would go 7 plus 10x. But they didn't match, right? So if you did factor that, it's okay. It should accept this answer. We'll type it in and see if they do. So 56 plus 21x over 56 plus 80x good. Right, that one is going to be the most work of all, so I'm going to leave it and see if I can do maybe one more. Yeah, let's do number 8. That one might bother you guys. So 3 plus 6x to the negative 1 over 1 minus 4x to the negative 2. Right? This piece, you're going to move this and make a denominator. You're not going to move it below this line, but you're going to put it under the 6. So you're going to rewrite this as 6 over x to the positive 1. You're going to rewrite this as 1 minus 4, and it's going to be x to the positive 2. So that's the one we're going to clean up. Your common denominator is going to be an x squared, but we're going to distribute it so it's going to go beside every piece. All right, and so let's see what we got. So we have 3x squared, right? 1x cancels here, so plus 6x. Right, this one, x squared times 1 is going to be x squared. And this one, the x squareds are going to cancel, minus 4. So we might have to factor to reduce. We can take out a 3x, and that leaves us an x plus 2. And this denominator is a difference of squares. X plus 2, x minus 2. You are going to get some canceling here. So you end up with 3x over x minus 2. Good. This one just use s squared. It'll be similar. All right, let's do 11, and then we'll backtrack to that one that I said is harder. We should have time. So we have 2 over m squared n plus 4 over m n squared over 6 over m squared n minus 1 over m n squared. So you need the LCD for all 4 fractions. All right, so for your m's, you want to take the most. We're going to need m squared. For your n's, you want to take the most. We're going to need an n squared. That's what we're going to put beside each piece. So m squared, n squared. M squared, n squared. M squared, n squared, and m squared, n squared. All right, now we're going to clean up. So my m squared goes out here. 1 n goes away. So this one leaves me 2n. The next one, 1m goes away. The whole n squared goes away. So I'm left with 4m. Right, down here, m squared goes away. 1n goes away. So I have 6n. right? And this one, one m goes away, both n's goes away, so I have minus m, right? You could take out a GCF in the numerator, so 2 times n plus 2m. There's nothing to do down here. So since it doesn't reduce, you could leave it here. So let's just check it. All right, it should have also accepted the other one. All right, I'm going to try to go back to that one that I said was hard. It's a little more work. Number 7. So we have 4 over x minus 1 minus 1 over x plus 1. And this is over x minus 1 plus 1 over x plus 1. For your common denominator, you're going to need x minus 1, x plus 1. So you have to multiply by that whole thing, all 4 pieces. All right, I'm going to stick it on here first because this looks like the easiest spot. All right, now we'll clean up. So x minus 1 goes away. Yeah, I was afraid that would happen. X plus 1 goes away, x minus 1 goes away, and x plus 1 goes away. So let's see what we have left. And we have a 4 times x plus 1. So that will be 4x plus 4. All right, here we have minus 1 times x minus 1. Take that with you when you distribute. So that's going to be a minus x and a plus 1. Right down here, you're going to have an x squared plus x. And this one will give us an x minus 1. All right, so we have 4 minus 1 is 3x plus 3. And down here we have x squared plus 2x minus 1. Could we factor? I'm going to go back this way. You could take out a 3, and that leaves x plus 1. Down here, if we try it, I'm going to have to use 1 and 1. And because that's the only way to multiply and get 1. But those are going to cancel, and it has to be different signs. So it's not going to factor. So it is going to need to stay there. Okay, Mrs. H has an error. That's embarrassing, huh? How many has she had today? All right, let's see what on the numerator I did wrong. Okay, so I had a 4 here, and it's gonna, the x minus 1 cancels, and it goes times x plus 1. Right here. Right, because 4x plus 4. No, 4x plus 4 is what I get there. That's okay. All right, and here it is a minus. All right, the plus 1 cancels, so this is minus x and plus 1. Here is what I did. 4 plus 1 is 5, not 3, Mrs. H. Uh, 4x minus x is 3x. This one's okay. 3x plus 5. All right, so arithmetic error right here. Okay, we better stop on that. Right. You guys have an awesome day. Thanks for hanging out with me today. And I'm going to find out about that other one. I'll look through and make sure I didn't have an error. But they didn't like my opposite stuff, so we'll see. I'll get back to you.